Okay, so today we're talking about dilations. We're going to graph dilations on a coordinate plane, and we're going to find scale factor of a dilation. As a gift for her grandparents, Sierra is enlarging a favorite 4-inch by 5-inch family photo of her computer. So suppose she enlarges the photo to 8 by 10 inches. Compare and contrast the original photo and the enlargement. Okay. So if we take a look at the original is 4 by 5 inches. The enlargement is 8 by 10. So you could say that the dimensions of the photo double in size. So if it doubles in size, what is the scale factor from the original photo to the enlargement? Well, if it doubles in size, it's 2 times as much. So we could say a scale factor of 1 to 2. Okay? And that's what a dilation is. It's going from one image or one shape to a bigger shape or to a smaller shape. Okay? So recall that a transformation maps an original figure onto an image. Translations and reflections are two transformations that change the position of the object. A dilation is a transformation that enlarges or reduces a figure by a scale factor. So a translation is one that just shifts a figure or shape to a different direction, to a different place. A reflection is where it flips over a line. Okay, so it's like a mirror copy. And then a dilation is actually changing the size. Okay, so we're changing the size. And that's what we're talking about today. So when the center of a dilation is the origin, you can find the coordinates of the image by multiplying each coordinate of the figure by the scale factor. So we can use the notation xy being k times x and k times y to describe the dilation. Now remember, k would be our scale factor. All right. So we have a figure. This figure right here has vertices of j is 2, 4, k is 2, 6, m is 8, 6, and n is 8, 2. Remember, vertices are the corners or the angles of the figure. So graph the figure and the image of the polygon after a dilation with a scale factor of 1/2. So we could say that the dilation is xy, which is 1/2 x and 1/2 y times y. So multiply the coordinates of each vertex by 1/2. Then graph both figures on the same coordinate plane. So the first figure is JKMN in blue. Okay? So all we do is we just plug in what they give us. Okay? And that would tell us where that shape is. Then we take each one of those XYs and we times them times our scale factor. Now you will notice on the new image, it's still JKMN. However, when you make a new figure, you add the little symbol above it, okay? So for example, if I go from J and I go to a new symbol or a new figure, it would be like this. And if I would go from that figure to a new figure, it would be like this. And if I go to that one to a new one, it would be like this. So you just keep adding a mark for each new figure from the original figure. Okay? So when I say 1/2 times 2, I get 1. 1/2 times 4, I get 2. So that would be 1, 2. So I come over to my coordinate plane, and I put my point right here for 1, 2. Then on 2, 6, I multiply both of them by 1/2, and I get 1/3, or 1, 3. That would go here. Then I multiply 8, 6, both by 1/2, and I get 4, 3. That would go here. And then I would multiply 8, 2, both by 1/2, and I get 4, 1. And that goes here. And then, of course, I label them. And you can see that the figure I would connect the coordinates with a line, obviously, to make the figure. And you can see that the figure is the same figure. It's just smaller. We did a dilation of 1/2, so it would be half as big, okay? All right. So let's look at another example. It says a triangle has a vertices of A is 15, 12, B is 9, 12, and C is 9, 6. Find the coordinates of the triangle after a dilation with a scale factor of 1/3. So we're not drawing anything on this one, okay? So the dilation is xy. So all we have to do is multiply each of the coordinates by 1/3. So 15, 12 would be 1/3 times 15 and 1/3 times 12. That would give me 5, 4. Then 9, 12, we would take 1/3 times 9, 1/3 times 12, and that would give me 3/4. And then 9, 6, we take 1/3 times 9, 1/3 times 6, and that gives me 3/2. Okay? So all we're doing is multiplying everything by the scale factor. Okay? All right, let's take a look at a couple of examples that we can work together. Or you could try these and then come back. So we are to find the vertices of each figure after dilation with the given scale factor k. Then graph the image. So on the first one we have A is 2, 2. So we could say 1, 2, 1, 2, which is here. And we have B is 0, 4, which is here. And we have C, which is 1, 2, 3, 4, I believe here. And we have D. 1, 2, 3, 4. Which would be about right here. It's a little bit off the grid. And that's where it's going to be, kind of give you an idea. They don't tell you to graph the original, they tell you to graph the new one. I just wanted to kind of put the points there so you could kind of see where it is before we move forward. So we would go A would be 2 times 1/2 and 2 times 1/2. So A would become 1, 1. So it would go, oh, let's do this. Let's do them all first. Let's go B. B is going to be 0. Forgot how I was doing it here. It's going to be 0 times 1/2 and 4 times 1/2. So B is going to be 0, 2. And then C is going to be 4 times 1/2 and 8 times 1/2, which is going to be 2, 4. And then we have D, which would be 10 times 1/2 and 6 times 1/2, which is going to give us 5, 3. All right. So then we could take a look and we can see how this is actually going to work. So we could say A is 1, 1. So that's going to go right there. And then we have B, which is 0, 2, which would go right here. And then C is 2, 4. And then D is 5, 3. Just like that. Okay? My lines are a little crooked. but that's how you would do it. And so this is 1/2 the size. It looks a lot smaller, but it's actually just with a scale factor of 1/2. Now let's take a look at 3 with a scale factor of 3. So in this one, they do not give us any of the vertices. We have to find them, and then we have to solve it. So, and this is one of your homework questions as well. So we have NOP. So we have N. So the first thing I want to do is find my vertices. So that would be 1, 1. And then I have O, which is going to be 1, 2, 3, 1, 2, 3. So that's 3, 3. And we have P, which would be 3, 0. And then we have a scale factor of 3. So we're going to say this is 1 times 3 and 1 times 3. And this is going to give me my new figure of 3, 3. Okay? Then I would go 3 times 3 and 3 times 3. And that's going to give me my new figure of 9, 9. And then lastly, I would have 3 times 3 and 0 times 3. It's going to give me my new figure of 9, 0. Oops. Okay, we'll move that up there. All right, now I can plug it in and see where it is. So I have 3, 3, which would be right here. And that's going to be N. And then I have 9, 9. Which is right here. And then I have 9, 0, which would be right here. And that would be my figure. You can see that it's still in the same area. It's just 3 times as large. Okay, so we just did a scale factor 3 times as large. All right. So when you're dealing with scale factor, if k is greater than 1, so any number greater than 1, you're going to have an enlargement. Okay? If it's 1, it's going to be the same size. But if it's larger than 1, you're going to go from a small figure to a big figure. If your scale factor is between 0 and 1, you're going to go from a big figure to a small figure. Okay? So let's take a look at this one. So this says when you know the size of a figure and the size of the dilation of that figure, you can determine the scale factor of the dilation. So now we're going backwards. We know 2 figures. We are now going to look for scale factor to figure out what the scale factor is. So this one says, Kylie drew a sketch of a mural that is painted outside her school library. What is the scale factor of the dilation? So to find the scale factor, we can write a ratio that compares the length of one side of the original image to the length of a corresponding side of the dilation. So when an image is on the grid, subtract the x coordinates to find the length. So this is the original, okay? Because you'll notice on the new one, we have the little marks above the A and the B. So the original is AB. So we could count over 1, 2, 3, 4. So the x would be 4, okay? Or we could look at this and say this is 4, 1, 2, 3, 4, 5, 6, 7, 8, 4, 8. And this one is going to be 1, 2, 3, 4. Looks like 12, 8. But all you really need is the x values because you're looking at how long it is on this one, okay? So we would say 12 minus 4. 12 minus 4 is 4. And then on the other one, we have 1, 1, 2. So this is 1, 2. And on this one, it'll be 1, 2, 3, 3, 2. So again, all I need is the x values. So 3 minus 1 is 1. So that would be 1 over 4, and that would be a dilation of 1/4. Now, if you forgot which one goes on top, which one goes on bottom, and you flip that, you would have a dilation of 1/4. I'm sorry, a dilation of 4. Well, you know you're going from a big figure to a small figure, so you know it has to be less than 1. So if you ended up with 4, then you know that you probably need to flip your problem that you're working on and then end up with 1/4, okay? Because 1/4 would take it smaller. All right, very good. So let's look at this. We could do images as well. So a drawing of a school mascot is to be increased as shown at the right, so it can be painted on the gymnasium doors. What is the scale factor of the dilation? It's the same thing. We take a look at 2 points. So in this case, we're going to go from here to here. And that's the line that we're going to use. And we use the same one on a smaller, okay? Same exact line. So I take the x coordinates and I subtract them. 9 minus 3. Then I take the x coordinates of the smaller one, would be 3 minus 1. And that would give me 6 over 2, or 3. So I would have a scale factor going from small to big would be a scale factor of 3. Okay? And again, we know that because it says a drawing of a school mascot is to be increased. So it's going to get larger. So if it's going to get larger, it has to be greater than 1. So that's where you would have 3, a scale factor of 3, going from the small to the large. Okay? So it would be a scale factor of 3. So let's look at this one. It says, for his mother's birthday, Paolo wants to enlarge a 3 by 5 inch photo to an 18 by 30 inch photo. What is the scale factor of the dilation? Okay, so we could take any side that we want on this one, okay? And we know that just like we were talking about in proportions, okay? If you can set a side up and then, so for example, if we have a 3 by 5 and we have an 18 by 30, we know that these two sides, they're listed first. So we know that those two sides would be proportional to each other. So I could say 18 divided by 3 is going to give me 6. So it would have a scale factor of 6 inches. Okay? Now I know that because he wants to enlarge it. Enlarge. So we're going from small to big. So the scale factor has got to be greater than 1. Okay? Enlarge. All right. One more. So let's see. Found a store that will take a regular photo and transfer it to an enlarged version of the photo onto a blanket. She would like to order one of her grandparents. The photo she chose is a 4 by 6. The blanket will be a 50 by 75. What is the scale factor of the dilation? Again, we're wanting to enlarge. So we're going from small to big. So I would take the first two numbers is fine. So I could go 50 over 4. And when I divide that, I'm going to end up with, that would be 12.5. So it would have a scale factor of 12.5 inches. Okay? And again, it's because I know it's going larger. If it would have said we're going to reduce, we're going to make smaller, then I would put the smaller one on top, and I would have ended up with 1 over 12.5. Okay? So you have to know which way you're going. Are you going from small to big or big to small? Okay? All right. If you got any questions, let me know.